Hi, this is Ms. Schelt, and so this is for my students in honors pre-calc here at Lexington High School doing day 5 of our Trig Identities unit. And so this is not proving any more new identities that are the classic ones that are normally taught. These are useful identities, but the purpose of today is really just to practice the process of deriving new identities. But we'll still derive some pretty cool things. All right, let's go. All right, I just want to credit the Brown Advanced Math textbook, which is where these are from. And this is what we will be doing. We'll be doing some or most of these together. Let me get this set up here so that here we go. All right, so this is from the Brown textbook, section 110-1, exercises 39 through 41, excuse me. All right, let's read. Sometimes a product involving a sum can be more easily solved if the sum can be expressed as a product. So we have already done like sine and cosine of a sum or cosine and sine of a difference. But what if I start with the product of two cosines? Not cosine of a sum, but the product of cosines. And so it turns out this is a way to express the product as sums of a cosine of a sum and difference. So let's read this one carefully. Prove that cosine A cosine B equals 1/2 cosine A plus B plus cosine A minus B. All right, so I'm gonna start with this right side and then substitute known identities for cosine A plus B and cosine A minus B. I encourage you right now to pause the video and try it yourself, and then unpause, and then you can see how I do it. So I'm gonna start with this right-hand side. So I'll use our HS to just as shorthand for right-hand side. And so this is 1/2, big parenthesis, cosine of a sum. So it's cosine A cosine B minus, because the cosine of a sum formula has the opposite sign right here, sine A sine B, and then this sign's a plus, cosine of a difference, cosine A cosine B minus sine A plus rather, because this is the opposite sign, sine B. Okay, and then I'm going to simplify this. So what do I notice here? I notice that these two terms are the same. So these are like terms that I'm going to combine. And then these two are the same with opposite signs, so they'll cancel out. So this is 1/2 times twice cosine A cosine B, which is just cosine A cosine B, which is what I was trying to get. So, all right. Okay, now let's do something similar for sine A, sine B, although it's going to be a little bit trickier because I'm not telling you the answer. So you're not going to be able to use the answer to say, oh, it's equal to the left side. Let's read it. Now consider sine A times sine B. How would you modify your work in part A to find a formula for sine A times sine B? Your formula should involve cosine of A plus B and cosine of A minus B, but I want to end up with sine A sine B instead of ending up with cosine A cosine B. So basically what I want you to do here is guess the formula. So it's not going to be exactly this, but it's going to be similar. Guess the formula that would yield sine A sine B and then verify that that's correct. So I encourage you to pause the video and then guess the formula and then unpause it to this number 4 here. All right, so let's read it. This problem will lead you through the steps of proving a theorem called the law of tangents. All right, so in triangle ABC with the usual notation, so what that means is like if you have angle A that's opposite little side A, angle B, little side B, angle C, little side C, with the usual notation that A minus B over A plus B equals this, tangent of half A minus B over tangent of a half A plus B. So how do I know that this is true? So think about it, pause, give it a thought, and then unpause when you're ready. All right, this is the law of sines. So using the law of sines, I know that sine A over little a equals sine big B over little b, which means that if I multiply by a on both sides, and then I also divide by sine b on both sides, that a over b, and then I put the right side on the left and the left side on the right, a over b equals sine a over sine b. Okay, so now I'm going to do this problem and then the beginning of C for us. All right, so show that a plus b over b equals sine a plus sine b over b, and show something similar for the difference. Okay, so from a, I'm just going to copy over what I have from a here. So from a, I have a over b equals sine a over sine b. All right, now I need to go from here, and this is my goal. So let's think about how I could do that. I have this fact here, right? Here, I'll outline it. So this is the algebraic concept that I'm going to use, okay? So notice I want to get to a sum over like an a plus b over b, literally. Actually, that would be a b. And so I'm going to start with two terms. So here is how we're going to get started. I'm going to add 1 to both sides. Okay, so I know that this is true. So I can treat this, first of all, I can treat this as an equation and add 1 to both sides because this is an equation that I know it's true. It's not an identity I need to prove. I know this is true because it's the law of sines. So let's try. A over b plus 1 equals sine a, over sine, I'm going to start writing in red, sine a over sine b plus 1. Okay. This is as far as I'm going to take you. So I will tell you though that the next step to get here is to get common denominators. And then you're going to show something similar for that. All right, so I'll let you pause the video and do that now or do it later. All right, so hopefully you've finished for B now. I'm not going to show all the work. I want you to do some work on your own. But this is me finishing A, and then for B, this is the result you should get. So now I want to show that A minus B over A plus B is this. All right, and then eventually I'm going to go from sine to, remember, this is my goal. Eventually I'm going to go from here to there. It's going to be a few steps till we get there, but this is my goal, is to prove this law of tangents. All right, so A minus B. So I see an A minus B here, and I see an A plus B here. So I'm going to take the quotient of this and that. So A minus B over B over, so this over that, A plus B over B equals this over that. All right, so let me do big, and then I'm gonna have sine A minus sine B over sine B, and the denominator is this, sine A plus sine B over sine B. All right, so then now this is pretty straightforward to simplify. These cancel. To show that they're canceling, if you want, you can multiply by b over b, and they cancel out. And then this, you could multiply by sine b over sine b to show that that cancels. This is allowed because this is a form of 1. So I get a minus b. I get what the result I was trying to show. Plus b equals sine a minus sine b over sine a plus sine b. Now, there's a mistake in here. It says using the identities from number 2. So I actually shortened this exercise and I cut out some really important identities that they used to be in here, but they are not these identities from number 2. Because as you can see here, the identities from number 2, I have the sum of cosines, all right? And I have the difference of cosines. But what I actually need is the difference of signs and the sum of sines, which I don't have. So you can take my word for it that we could do a really similar process. Like I could have made a 2c if I'd wanted to, 2c. So let's say that 2c would be sine of a plus sine of b, or in other words, like I could have done sine of x plus sine of y, dot, dot, dot. So let me just tell you, if we had done those, what you would get. So these identities we're going to use, so they are not from number 2. So sine of x plus sine of y equals 2 sine of 1/2 a plus b cosine of 1/2 a minus b, like that. So that's an identity that we didn't show. I didn't have you show, but I could have. So we could have used it for just this moment. But here it is. The other identity you need to know is sine of x minus sine of y. The difference of two signs is 2 cosine of 1/2 a plus b, and then sine of 1/2 a minus b, right? So these are the two identities you're going to use for this. So I need a minus b over a plus b equals this, and then so you're going to substitute in for sine of a minus sine of b, you'll use this formula, and then for the denominator, you'll use this formula. And I will leave that as an exercise for you to figure out, and you should end up with this formula, which is the law of tangents. All right, that's the end of day 5. After this, it is bookwork, which you have space to do. This is the problem set due our next class, and I do have a copy of the Jumana book for you if you need. All right, thanks. Signing off. This is Michelle signing off. Bye.